So this is the AB FRQ from 2021. Yeah, so it gives the graph of f and says it's 4 line segments, and it gives us g of x, which is the integral from 0 to x of f of t. The first question asks us on what open intervals of the graph g concave up. So in order to find concave up, we need a second derivative of g. G prime, g of x equals integral of x f of t dt. So the derivative of that is just when we plug this in here, and because the derivative of this is 1, it just gives us 1 times f of x. Um, and we don't care about the 0, 2, because it's in an indefinite interval. We would just subtract it. We plugged it into the antiderivative, and that would give us a constant. So it doesn't really matter because it cancels out because of the derivative. So then g double prime of x equals f prime of x. But then, if you recall, it's 4 line segments. So there's 4 times the lines change. And these are all not differentiable because the limit from both sides using the limit definition of a derivative are not equal. So therefore, a derivative cannot exist at any of these points, which means we need to solve for each one of these. So we do that by just finding the slope. We just use it and find the 2 points, preferably the endpoints, and just plug it in to the slope formula. So first point is -4, 0 to -2, 6, and when we plug it in, we get 3, which is positive, and therefore g double prime of x is positive at this interval. So this works. And we end up just repeating this like about 4 times. So -2 to 6 to 0, 4, 6 minus 4, -2 minus 0 equals -1. So because this is negative, this means g prime of x is concave down at that point. So it's not included. And now we just keep moving on. Equals -4, and like I said earlier, this is negative, so it doesn't apply. And the last value is 4 to 6, 0, 1. So this is positive. So then, because the question also asks on an open interval, we are not including. So -4 to 2 union 2 to 6, because that is where g double prime is positive. Number 2 asks us to find p prime of 3. So p of x equals g of x times f of x, and when we derive, we need to use the product rule. Common mistake would just be finding the derivative of g and then multiplying it to the derivative of f, but that's wrong because it doesn't apply to the product rule because they're 2 separate functions. So when we do this, we get f of x squared plus equals 0x f of t dt times f prime of x. And because they asked us to find it when x equals 3, we need to look at the graph. 3 here, like this. Now we need to refer to the graph. We look at, this is where it's 3, and this is -3. So this equals 9 plus, now the integral here is this area. Oops. It's this area. And the bottom here, this part is negative because it's under the x-axis. And we can recognize that this area and this area right here are the same because one of them is negative, they'll cancel out. It means the integral of 0 to 3 is just this value here, which is a trapezoid, and we don't need to use the trapezoid formula because we can just use a rectangle plus a triangle. 1 times 3 is 3, and then 1 times 1 over 2 is 1/2. So the area, the integral is negative 7 over 2. Times. Now we need the derivative here. Because this is a line, it means it's linear, which was given by here. F is 4 line segments. Because we already found that value in A, right here, we don't need to find it again because it would always be increasing by the same amount. So every single point would have the same derivative, which is also given by MBT, times 1, which gives us 11 over 2. Now we're on number C. So it gives us the limit x to 2 d of x squared minus 2x, which is the same thing as the limit of x equal 0x dt x squared minus 2x. Immediately we'll recognize that the limit at the bottom equals 0. So something has to be up. And when we look at the graph, we can see that the integral from 0 to 2 is this area plus this area. But this area is negative because it's under the x-axis. And we can recognize, because both of these have the same base and same height, these have the same value, but one is negative. So this gets us 0 because it's essentially saying this, let's say this area is A plus this area also being A, just 0. So that means the limit of the top also to 0. So we'll have a limit that gets us 0 over 0. And that's not indeterminate because this is the exact conditions of L'Hopital. When we use L'Hopital's rule, we derive the top and the bottom separately. So the derivative of the top, remember to keep the limit as f of x over 2 to x minus 2, which equals, when we look here, we get at 2 is negative 4. Negative 4 over 4 minus 2 equals negative 4 over 2 equals negative 2, which is our final answer. Last part asks us, does the average rate of change ever on this interval? So before we even start with this question at all, we need to know if G is differentiable. And G is differentiable because when we derive this, we get f of t. And it's a continuous function, which means G is differentiable. And it is also continuous because there's no like gaps in between. You'll always get a value at some point. So that means we can start. We need to find the average rate of change. Then we can determine if there's ever a point. So we need to determine G negative 4 equals f of t dt. When we look at the graph, it's this area. Which is triangle, 2 triangles plus 1 rectangle. And when we use geometry, we get this equals, I think it's negative also because negative on top, 2 times 6 over 2 plus 2 times 2 over 2 plus 4 times 2. We get this because we get the area of the rectangle is 4 times 2, the area of the top is 2 times 2 over 2, and the area of this is 2 times 6 over 2, which equals negative 16. G of 2 equals 0 to dt, which we're calling from C. The area of both of these are the same, and one is negative, so it gets us 0. So when we do the average rate of change, we get negative 16 minus 0, or negative 4 minus 2 equals negative 16 over negative 6 equals 8 over 3. Because G is continuous and G is differentiable on this interval, it means by MVT, it is guaranteed that at some point on negative 4, 2, there will be an f of c such that x equals c such that f prime of c equals 8 over 3. And it's by MVT, which is the most important part of this question because MVT is the theorem that justifies all of this.